Hello students, hope you have watched video 1 and video 2 of electricity. So in the previous videos we have discussed about what is electrical current and what is circuit diagram. I hope you are clear about that. So today in today's video lecture we are going to discuss about what is electrical potential and potential difference. So we already know about electrical current, but we know that why these electrical charges flow inside the wire. So our first question for the discussion would be, what makes electrical charges flow in the circuit? What are the external phenomena, or what is the external force which make it happens? So let me take a water analogy over here. Let's say if I am having a horizontal pipe in which water is filled. Now can you answer that water will flow automatically inside this pipe? Yes or no? I think it will not flow. But if I tilt this plastic pipe a little bit, then water will automatically flow. So why does it happen? The reason behind it is, here point A of this pipe will be having at a higher atmospheric pressure and point B will be having a lower atmospheric pressure. So here between these 2 points there is a pressure difference, and due to that pressure difference water is flowing. In day-to-day experience you also would have known that if we want to send some water through pipe from, let's say, ground floor to second floor, third floor, then we have to connect the pipe with the pressure pump. So that pressure pump is giving some kind of the force, some kind of the thrust, so that water can flow inside the pipe. Now, what is that external thrust, or what is that external pressure which make charges flow inside the wire? So similarly, electrical pressure, that is a potential difference, is required to move charges inside the wire. So you can have an analogy over here like that electrical pressure or potential difference is working like a pressure pump. So what is that device? What is that pressure pump? Can you imagine? Can you guess? Yes, it is nothing but this cell. It is a cell which is giving power, which is giving energy to electrical charges to flow. Okay. Now, so yes, cell and battery provides the potential difference when it is connected into the circuit. In order to maintain the current inside given circuit, cell or battery has to expend its chemical energy. Let us try to understand this thing with the help of the example. Let's say this is a pipe, a U-shaped pipe, a person is there, and the full-time job of this person is, there are some balls here. Ball is going from point A all the way to point B. Now, ball cannot go automatically from point B to point A. So what this person does is lift the ball from point B, and he will keep the ball at point A. Now ball will automatically comes to point B. Once again a person lifts the ball from point B to point A, ball will automatically come to point B, and so on. So this cycle continues. Okay. So ultimately the person will be tired. A person will be tired and he will no more in the condition to do the same activity. Okay. Initially when he had the energy, he had some power, he would be doing this activity, but ultimately the energy drains up and he will no more be able to continue with this activity. So in the same manner, let's say whenever we are having a cell, whenever we are having a battery, when it is new, it gives us the, let's say, light or any other work power in the very nice manner. But after a while, when the energy has been utilized, then we, in day-to-day life we say that हमारी जो बैटरी है उसका power वो discharge हो गई है, be it a phone or be it a torch or be it any other thing. Okay, so this thing is understood. Okay, so the technical definition of the electrical potential. Here in this example we can say the point A is at higher potential and point B is at a lower potential. So electrical potential difference means the difference between potential between A and B. So electrical potential difference between 2 points in the circuit. Let's say this is the circuit. So from the electrical potential difference between 2 points, let's say point A and point B in the circuit carrying some current. Here a battery is connected, so current is from point A to point B. Is work done to move some amount of charge from one point, that is A, to another point B. Let us try to understand the definition of electrical potential difference once again. Consider any 2 points in your circuit in which the current is flowing. So this is my circuit, a battery, emitter, bulb, resistor and key. When key is closed, the current is flowing. So electrical potential difference between any 2 points, here the point A and B I have taken. So work done to move some amount of charge, any amount of charge from point A to point B. Now in doing this activity, the battery has to expend some amount of energy. So from point A to point B, if we want to push some amount of charge, then that is known as the electrical potential difference. So the mathematical formula of potential difference, the symbol is V, is work done per unit charge, W over Q, and the unit is joule per coulomb, that is nothing but the volt. Volt is a name of the scientist in honor of which the symbol of electrical potential difference is known as volt. Let us move further. If we want to define what is 1 volt, okay, so here the left hand side of the equation should be 1, and to make the left hand side of the equation is equal to 1, the numerator and denominator should also be equal to 1. So let us define. If 1 joule work is to be done to move 1 coulomb charge from one point of circuit to another point, then electrical potential difference between these 2 points is 1 volt. So from point A to point B, if 1 coulomb charge is to be moved, and by doing so the energy spent, energy required is 1 joule, then electrical potential difference between these 2 points is 1 volt. Is that clear? So 1 volt is 1 joule upon 1 coulomb. It is V is equal to W over Q. So this is another mathematical formula which will help you to calculate some numerical. In the previous lectures, you might have aware about the formula electrical current I is equal to Q over T. This is another formula. Voltage V is equal to W over Q. Okay, so based on this formula, let us discuss one example which is given in your book very quickly. So the example goes something like this. Example number 12.2 given on the page number 202. How much work is done in moving a charge of 2 coulomb across 2 points having potential difference 12 volt? So here the charge given is 2 coulomb and the potential difference between these 2 points is 12 volt, and what we need to find? We need to find how much work is to be done. So we can, we can make the subject of this equation W. So W is equal to V into Q. Q is given, V is given, 12 into 2 is 24 joule. So work required to move charges of 2 coulomb between these 2 points is 24 joule. Is that understood? Okay. The next is potential difference is measured through the device which is known as voltmeter. So voltmeter is a device through which we will be able to measure the potential difference between any 2 points within the circuit. For example, here across the bulb, that means between these 2 points, between point A and between point, between point A and B, if I want to measure the potential difference, then I need to connect a voltmeter here. Okay, this is plus and this is minus. Okay. Now can you see that I have connected voltmeter in bit different fashion, in bit different manner than ammeter? Ammeter is always connected in series, while voltmeter is always connected in parallel. So you must remember this difference. Ammeter, as and when it is there in the circuit, it should be always connected in series. However, when voltmeter is there, it should be always connected in parallel. Correct? Lastly, there are some circuit symbol when you are dealing with some electrical circuits. There are some symbol about which you should know. So let us discuss very quickly. So what is the difference between cell and battery? By and large, both are same thing, but when only one single device is there, it is called cell. But when multiple devices are connected, like in your torch or in your some toys, rather than putting only one cell, generally in the wall clock, there are only one cell, so it is known as a cell. But in toys and in some other devices, there are 3 to 4 cells. So when multiple cells are there, it is known as the battery. In circuit, when key is open, that means here key is closed. When key is open, that means electrical current cannot flow. So here dot is not there. But when key is closed, a dot should be there. The bulb, the very general symbol. The joint of the wire, it is connected here like a T, inverted T. Okay, so here this wire and this wire, a vertical and horizontal wire has been connected. But when wires crossing without joint, that means the one wire is not touching another. It is something like this. One wire goes like this, another wire goes like this. They are not touching each other. So it is like a jump. Okay, so horizontal wire and vertical wire, they are not touching each other. The next thing is resistor. Though we have not discussed about the resistor, just remember the symbol. So resistor is just a zigzag path. Okay, and there is something called a variable resistor. It is also known as a rheostat. Generally, resistors will be having a fixed value. Let's say 1, 2, 3, and so on. 1 ohm, 2 ohm, 3 ohm. But there are some resistors whose value can be varied through some knob. So when the arrow is there, it is a variable resistor. Lastly, you must be knowing the symbol of ammeter and voltmeter. So ammeter symbol A, plus and minus, voltmeter V, plus and minus. Okay class, so I hope today whatever we have discussed in about the electrical potential and potential difference must be clear to you. There are something I have written in this board. This is for your self practice and self study. So by watching this video, you will be able to answer question number 1, 2 and 3, which is given on page number 202 on your textbook. Moreover, exercise 5 given on page number 220